Hello, this video is titled What is covalent bonding and how is it represented? This video will just focus on covalent bonding in elements. There will be another video that you will see on my channel that is looking at covalent bonding in compounds. Now to start, let's just recap what is a covalent bond. So a covalent bond is occurring between two nonmetals. And you are also looking at the sharing of electrons. So you can see here it says rather than transfer electrons like in ionic bonding, the atoms share their electrons. So this here is sodium chloride. Before you would have looked at this in ionic bonding and you saw the outer shell electron of sodium go to the outer shell of chlorine, and then you drew a sodium atom and then you drew a chlorine atom. Okay, that is ionic bonding. Okay, what we're going to look at now, which is below, is looking at covalent bonding. So covalent bonding, rather than there be any kind of transfer of an electrons, they actually share electrons. And what you end up with at the end is what we call, this is what it would look like. Okay, and you can show here, this is what it's very similar to a Venn diagram in maths, and you can see here that fluorine, so this is fluorine F2, fluorine has shared its electrons. So this fluorine had 7 of its own, and this fluorine had 7 of its own electrons. And what it's done here is they've come together, and these 2 electrons in the middle are being shared. Okay, so I'll just take them apart again so that you can see. Okay, so this fluorine has got 7 of its own electrons. This fluorine has got 7 of its own. Now remember, in bonding we are looking at completing shells. We're looking at filling shells. Okay, so this fluorine has 7. It needs 1 more to become 8. This fluorine has 7. It needs 1 more to have 8 electrons in its outer shell. Notice how we are only showing outer shell electrons here. Okay, now rather than transfer like it does in ionic bonding, they're simply going to share the electron. So this fluorine is going to share this electron with this fluorine atom, and this fluorine electron is going to be shared here as well. Okay, so I'll put them back together again. That's how we represent it. Okay, and notice how we've got 2 fluorine atoms, but one is dots and one is crosses. This is a diatom. Okay, so it's the element of fluorine, but fluorine goes around in pairs, which is why we've got 2 fluorine atoms here. Okay, so let's just recap what happened. These 2 fluorine atoms moved together, and now, like in a Venn diagram in maths where you have that sharing area in the middle of the 2 circles, well, in that sharing area is now the 2 electrons. So this fluorine has 7 dots, which represent its 7 electrons. Okay, it's then got the 1 here that it has shared with the other fluorine atom, so it now has a total of 8. This fluorine has its own 7, but it is now sharing the other electron, its remaining electron it needs for its full outer shell, from this fluorine. And that is how you represent covalent bonding. You represent them not using the square brackets, okay, and showing the transfer. Instead, you draw what essentially looks like a Venn diagram that you would see in maths, and you've got this sharing area in here. Okay, and all that does, all this, obviously you won't be able to do the moving of the atoms, but that's all I've done there. That is all covalent bonding is. So I always ask you to draw the atoms individually and then draw them when they're paired together, and that is, this video will really help you because I can visually show the atom moving. You obviously wouldn't get that in an exam when you're just seeing it in 2D. Okay, we're now going to go through loads of examples together. Remember, we are just looking at elements. Okay, so this is chlorine. Chlorine is Cl2, and these elements we're looking at, they are diatoms. Okay, diatoms. Their atoms go around in pairs. So all I'm going to do, okay, is draw an atom of chlorine, and it's going to have crosses. Okay, and I'm going to draw another atom of chlorine, but I'm going to draw the dots. Okay, and that's all you need to do. I would always recommend drawing the 2 atoms singly on their own, and then we'll bond them together. I'm just going to move these atoms over, and then I'll be able to fit my answer in. There we go. Okay, so all I've drawn is 2 atoms of chlorine there, and I'm going to bond them together. Okay, so I've got chlorine on this side. It's got 7 electrons in its outer shell. It's in group 7. This chlorine atom has got 7 electrons in its outer shell. Okay, they covalently bond together and they're going to share their electrons. So in terms of representing that, you would then draw, okay, a Venn diagram like so. Okay, sometimes exams give that to you, sometimes they don't, and all you do is fill the shells with the electrons that you previously had. Okay, so on this side I'm going to draw this chlorine atom first. I have 7 electrons here and I'm going to draw that onto this atom here. Okay, so 1, 2, 3, 4, 5, 6. Now because this chlorine has 7 and it needs to share 1 to get 8, it's going to give up one of its electrons into the sharing area. Okay, then this chlorine has 1, 2, 3, 4, 5, 6, and again because it needs 1 electron to fill its outer shell, it's going to share 1. So you draw it in the sharing area. Now you could have represented it like so. It doesn't matter which way around you do it. These 2 diagrams here are representing exactly the same thing. Doesn't matter which way around you show it. I personally tend to use this one just because you can see the sharing area nice and clearly, that you can see the covalent bond. This one, visually, students sometimes find it a little bit confusing. Either one of these is absolutely fine. Okay, so I'll just talk you through what I've done here. I've got 7 electrons on this atom of chlorine. It needs 1 to fill its outer shell. Okay, we are not having a transfer of electrons here, we are having a sharing of electrons. This chlorine has 7, it needs to gain 1. So what they do is each chlorine atom shares 1 electron with the other chlorine atom. So now it has 1, 2, 3, 4, 5, 6, 7, plus the 1 from the other chlorine. This chlorine has 1, 2, 3, 4, 5, 6, 7, plus the 1 from the other chlorine, 8. Okay, so they have covalently bonded together. The next one I'll show you is hydrogen. Hydrogen, 2 hydrogen atoms. Remember, I always say draw the atoms together separately, first of all. Hydrogen only has 1 electron in its outer shell, and they're going to have to share those electrons. And what they will do, again, I'm just going to move this over to show the bonding there. You draw your Venn diagram, and they've only got 1 electron each, so they can only share 1 electron each. Again, you could represent it this way as well. It depends on what you find easier. Next 2 examples then. I'm going to have oxygen. So now things start to get a little bit more tricky. Okay, we've got oxygen here, O2. Okay, so I'm going to draw 2 atoms of oxygen. Remember, we're only showing the outer shell electrons. Oxygen has 6 electrons in its outer shell. I'm going to draw 2 atoms of oxygen. Each has 6 in its outer shell. Okay, so with fluorine and chlorine, we looked at just 1 electron being needed to fill the shell. Well, oxygen has got 6 electrons, okay, in its outer shell. So therefore, it needs to, again, I'm just going to move this over. Again, it needs to share more electrons because there is only, sorry, I'm just trying to move this. Because in oxygen there is only 6 electrons in the outer shell. So rather than it just wanting to share 1 to fill its shell, it's actually going to need to share 2 because each atom has 6 electrons, and it needs to each atom needs to share or have 2 more electrons to fill its shell. Okay, so again, you draw the Venn diagram. So you draw your 2 circles like so. I'm going to draw those a bit better. Okay, so each oxygen has its 4 or 6 electrons, okay? So I've only drawn 4 there, but yet here I had 6, and that's because this oxygen needs to have 2 or share 2, because it needs to fill its outer shell, it is going to have to offer 2 into the sharing area, the covalent bond. So they go here like so. This oxygen has 6 of its own, okay? It needs 2 more electrons, so it's going to offer 2 into the sharing area, okay? And what it does is actually each cross in the sharing area is paired with a dot from the other oxygen atom, and your final result looks like so. Okay, now this comes up in other videos, but you can see here we've now actually got a double bond. Each of these is one bond, okay, between the 2 oxygen atoms. Each dot and cross is one bond, so oxygen actually has a double bond between it, whereas previously when we looked at fluorine and chlorine, they only had single bonds between them, okay, one dot and cross. Here in oxygen you have a double bond, okay. Nitrogen then, let's move on. Nitrogen, again, it's going to get a little bit more tricky. Nitrogen has 5 electrons in its outer shell, so I'm going to draw 2 nitrogen atoms, each with 5 in its outer shell. Okay, so you can already probably start to predict what's going to happen here. Each of these nitrogen atoms, they want a full shell of 8 electrons, but they only have 5 to start with, so they need to gain 3 electrons. So therefore they're going to have to share 3 electrons with each other. And in terms of representing it, again, draw your circles. They're going to have to each share 3. So there's going to have to be 3 crosses in here and 3 dots, okay? Now all you need to do is fill the remaining electrons into the shell. So if I had, I've put 3 of these electrons into the sharing area here. I've got 2 more I need to represent. So I draw those on the outer shell. Those could go anywhere. This nitrogen, I've put 3 into the sharing area, the covalent bond here, okay? Therefore, I've got 2 more I need to place. And I place those on the outer shell. Again, they could go anywhere. So nitrogen actually has a triple bond between each of the atoms, okay? Because you've got 1 dot and cross, 1 dot and cross, 1 dot and cross, a triple bond. Okay, I would really recommend now going through this video and playing it a couple of times over. The covalent bonding concept, I think students find more tricky than ionic bonding. So if this is taking you a little bit of time to grasp, that's absolutely fine. Replay the video, and I'd really recommend drawing out all of these atoms while the video plays so that you've got those in your notes. Okay, don't forget, any questions you have, all of you should have my email. Make sure you drop me an email and I'll try and answer as many questions as I can.